Hello guys, welcome to SLA tutorials. In the previous videos, we have discussed about arithmetic operators, comparison operators, assignment operators, logical operators, membership operators, and identity operators. In this video, we are going to discuss about bitwise operators. Before going to discuss about bitwise operators, we need to know how to convert numbers to binary format. There are two methods. First one, by number series, increasing the power value to 2. Second, by dividing number with 2. First we'll discuss about first method. Here we can see the table from right to left. Two power values are increases by one value. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 and so on. And the values of these two powers are 1, 2, 4, 8, 16, 32 and so on. If we want to convert number 10 to binary format, first we have to search the number 10 is present in the table or not. Here 10 value is not there, but by adding 8 and 2 we'll get the 10 value. So I will write once at 8 and 2 places, and remaining places I will write zeros, and the final result is 1010. This 1010 is 4-bit representation. If you want to write it in 6-bit representation, I will add 2 zeros at the end of left side. If we want to write it in 8-bit representation, the remaining 4 digits we have to fill with zeros at the left end. This is one of the method to convert number to binary format. Next, we will discuss about second method, by dividing the number with 2. If I want to convert number 10 to binary format, divide the number 10 with 2. 10 by 2 is 5. Remainder is 0. Next, 5 by 2 is 2. Remainder is 1. Next, 2 by 2 is 1. Remainder is 0. Next, 1 by 2 is 0. Remainder is 1. And write this all remainders in reverse order 1010. This is the binary format of number 10. In the both methods we got the same answer 1010. These are the methods to convert number to binary format. Next, bitwise AND operator. Next, we'll discuss about bitwise AND operator. If both the values are true, then only the result is true, otherwise false. Here we can see the table of values A and B. Here 0 means false, 1 means true. The output is 1 when both the values of A and B are 1. In remaining cases, the output is 0. For example, if I take A is equal to 7, B is equal to 5, the binary format of value A is 0, 111. The binary format of value B is 0, 1, 0, 1. If we use the bitwise AND operator for these two values, we'll get the output as 0, 1, 0, 1 because 0 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0, 1 and 1 is 1. The output is 0, 1, 0, 1. This 0, 1, 0, 1 is the binary form of number 5. So we'll get the output as number 5. We'll see in the Python IDE. A is equal to 7, B is equal to 5. Print A and B. We'll get the output as 5. Next, bitwise OR operator. Bitwise OR operator. If one value is true, then the result is true, otherwise false. Here we can see the table of values A and B. Here 0 means false and 1 means true. The output is 0 when both the values of A and B are 0. In other cases, the output is 1. For example, if I take A is equal to 15, B is equal to 6. The binary form of value A is 1111, and the binary form of value B is 0110. If we perform the bitwise operator for these variables A and B, we'll get the output as 1111. This 1111 is the binary form of number 15. So we'll get the output as 15. We'll see in Python IDE. A is equal to 15. B is equal to 6. Print A or B. We'll get the output as 15. Next, bitwise XOR operator. If both the values are same, then the result is false, otherwise true. Here we can see the table of values A and B. Here A value is 0, B value is 0. Both the values of A and B are 0, same. So the output is 0. Next, a value is 0, b value is 1. Both the values are different, so the output is 1. Next, a is 1, b is 0. Both are different values, so output is 1. Next, a is 1, b is 1. Both the values are same, so the output is 0. For example, if I take a is equal to 20, b is equal to 8, the binary form of value a is 10100, and the binary form of value b is 01000. If we perform the bitwise XOR operator for these variables a and b, we'll get the output as 11100. This 11100 is the binary form of number 28. So we'll get the output as 28. We'll see in Python IDE. A is equal to 20, b is equal to 8. Print a cap b. Output is 28. Next, bitwise negation operator. If the value is true, then the result is false, and vice versa. Here we can see the table of values a. If the value of a is 0, negation a is 1. If the value of a is 1, negation a is 0. Means this negation operator flip the value and give it as output. For example, if I take a is equal to 8, the binary form of this variable a is 1000. If we apply the negation operator for this variable, we'll get the output as 0111. This is in 1's complement, but Python interpreter will give the output in 2's complement. For that, we have a simple formula, minus of n plus 1. Substitute this value 8 in n place, minus of 8 plus 1. So, we'll get the output as minus 9. We'll see in Python IDE. A is equal to 8. Print negation of a. Output is minus 9. This is about bitwise negation operator. Next, bitwise left shift operator. It will shift bits towards left side. The general form of this left shift is double less than. For example, if I take a is equal to 25, the binary form of this number 25 is 00110001. If we do a left shift 2, means we are shifting 2 bits of this number towards left side. We'll see the process. Here we are shifting 2 bits, so at the end of left side 2 bits will be discarded and remaining bits will fill from the left side, and we have 2 empty spaces at right end. Fill them with zeros. This is the left shift of a number 25 by 2 bits. This binary form of number 100, so we'll get the output as 100. Next, bitwise right shift operator. It will shift bits towards right side. The general form of right shift is double greater than. For example, if I take a is equal to 20, the binary form of this 20 is 00010100. If we do a if we do a right shift 2, means we are shifting 2 bits of this number towards right side. We'll see the process. Here we are shifting 2 bits, so at the end of right side 2 bits will be discarded and remaining bits will fill from right to left, and we have 2 empty spaces at the end of left side. Fill them with zeros. This is the binary form of number 5, so we'll get the output as 5. This is about bitwise operators in Python. If you like the video, please click on like button and do subscribe for more videos. Thank you.